So we've all seen AI do some pretty mind-blowing stuff with images, right? From unlocking your phone with your face to spotting diseases in medical scans. But for the longest time, there's been this, well, kind of this dirty secret behind all that success, a huge hidden cost. Today, we're going to pull back that curtain and look at how AI is learning to see the world in a totally new way, breaking free from its old chains.
Okay, so just think about this for a second. How does a little kid learn? They're not sitting there with a million flashcards that say dog or car. They just look around, They explore, they touch things, they figure out how the world works through sheer curiosity. So what if we could get AI to do the same thing? To learn naturally, without us having to spoon-feed it every single piece of information. And that is the huge idea we're going to dig into today.
And look, let's be clear. Deep learning has completely changed the game in computer vision. No question about it. It's the magic behind your phone's photo app, automatically finding all the pictures of your friends, and it's what helps radiologists find tiny, subtle patterns in medical scans. The impact is absolutely everywhere.
But, and this is a big but, this amazing technology has this secret, hungry obsession. It has an insatiable appetite for one very specific thing: mountains and mountains of perfectly labeled data. And that obsession, it's become its single biggest weakness.
Right, so this is the old school way of doing things, what we call supervised learning. You basically show the AI a picture of a cat and tell it, this is a cat. Then you do that a million more times. It's like trying to build a skyscraper, but you have to hand label every single brick before you can use it. It works, for sure, but it's painfully slow, incredibly expensive, and it's a huge bottleneck. So the billion-dollar question is, can we find a better way to build that skyscraper?
So what's the first step away from this labeling nightmare? Well, it's a really clever middle ground called semi-supervised learning. And the idea is actually pretty simple, right? What if we could use all the data we haven't labeled to make the little bit of data we have labeled way more powerful?
This is exactly where this technique shines. I mean, the internet is just overflowing with unlabeled images, just sitting there. Semi-supervised learning asks a simple question. Can we use that giant, messy pile of data to help our model really learn from the small, clean pile of labeled stuff we already have? And it turns out, the answer is a huge yes. Semi-supervised learning is basically a bridge. It uses that ocean of unlabeled data to spot patterns, and that, in turn, helps the model get so much more out of the precious few labeled examples it has. I mean, we're talking about a massive, massive win for efficiency.
Okay, so how does this actually work? Well, one of the most brilliant methods is called the noisy student. You start with a teacher model that's trained on the good stuff, the data we've already labeled. Then that teacher takes its best guess on millions of unlabeled images, creating what we call pseudo-labels. After that, a bigger, more powerful student model comes in to learn from both the original labels and all these new pseudo-labels. But this is the really clever part you can see here, the noise. We don't just give the student the answers. We actually try to make things harder for it. We'll tweak the images a bit, that's called data augmentation, or we'll randomly switch off parts of its brain, which is called dropout. This forces the student to learn the real features of an object, not just memorize a picture. It has to generalize. And because it's being challenged, the student eventually gets even smarter than the teacher. And then the student becomes the new teacher, and the whole incredible cycle starts all over again.
Okay, so using unlabeled data is smart. It's really smart. But what if we could get rid of human labels entirely? What if the AI could just create its own homework completely on its own? This is where we go from clever tricks to something that feels like, well, like it's actually learning.
I mean, this is basically the holy grail, right? Can an AI really learn to understand what it's seeing from scratch with zero human input? It sounds like science fiction, but that's exactly what self-supervised learning is all about. So the trick, the big idea, is to give the AI a puzzle that it can only solve if it starts to understand the image. We call these pretext tasks. The goal isn't to find the cat in the picture. The goal might be to, say, put a scrambled up image back together. But think about it. To solve that puzzle, the AI has to learn what a cat looks like, where the ears should go, what a tail looks like. It has to figure out what a cat is just to win the game we gave it. The learning is a side effect. And this slide just lays it out perfectly. Supervised learning is like a flashcard. This is a cat. That's it. Self-supervised learning is more like showing the AI a picture of a cat tilted on its side and asking, hey, which way did I turn this thing?
To answer that question, it has to understand the structure of a cat, where its feet should be, that its ears point up. It learns the essence of what makes a cat, just by trying to solve that simple rotation puzzle.
And some of these puzzles, they're just genius. You can ask an AI to solve a digital jigsaw puzzle, or you can show it an image with a big chunk missing and ask it to fill in the blank. You can even give it a black and white photo and have it guess the original colors. Every single one of these little games forces the model to build a really deep understanding of the world, all without a human ever having to say, "This is a car."
Okay, so we've got a handle on learning with fewer labels, or even no labels. That's awesome. But what about speed? What about learning fast? What if you need to teach an AI a totally new idea right now, and you've only got a couple of examples to show it? This is all about teaching an AI how to be a quick study.
This whole problem has a name. It's called few-shot learning. So imagine you need an AI to identify a really rare type of bird, but you only have, say, 5 pictures of it. A normal model, it would just completely fail. We need a totally new way of thinking.
And the solution, well, it's a little bit of a mind bender. You stop trying to teach the AI what a bird is. Instead, you teach the AI the skill of learning. You're basically teaching it how to learn. It's a whole level of abstraction higher. This is meta-learning.
So how do you do that? Well, it's this method called episodic training. You can think of it like a learning boot camp. We throw the AI into thousands of these little mini tests, these episodes. In each one, it gets a few examples of something it's never seen, and then boom, it gets quizzed on it immediately. By doing this over and over and over, it stops memorizing answers and starts building the actual skill of learning fast from just a little bit of information.
All right, so everything we've talked about so far has just been about pictures, just pixels. But that's not how we learn, is it? We connect what we see to the words we read and the things we hear. The last big jump we're going to talk about is all about giving AI that same power to connect images and language to build a much, much deeper understanding of the world. The fundamental idea here, which was really pushed forward by models like CLIP, is to build what you can think of as a map of meaning. In this map, a picture of a dog isn't just pixels anymore. It's a point in this abstract space that sits right next to the point for the words, "a photo of a dog." They become neighbors because they mean the same thing. And let me tell you, this is a huge shift in thinking. The AI isn't just matching pixels to labels. By training on billions of image and text pairs scraped from the internet, it starts to learn the abstract concept of a bridge, or a pizza, or anything else. This makes it incredibly powerful because it can understand ideas it's never been explicitly trained to see before.
So when you put it all together, semi-supervised learning, self-supervised learning, meta-learning, and this multimodal stuff, what you've got is not just a bunch of cool academic ideas. What you've got is a brand new, seriously powerful toolbox for building artificial intelligence.
And this is why all of this stuff actually matters. Because in the real world, data is almost always messy and limited. These are the tools that let us build an AI that can spot a rare disease from just a few patient scans, or one that can identify a new pest threatening crops from a single photo a farmer takes on their phone. This is where these advanced techniques stop being theory and start solving real, important problems. So we've kind of come full circle, haven't we? We're shifting away from an AI that just memorizes data to one that actually learns, with flexibility and maybe even a little curiosity. And that leaves us with a really fascinating question to think about for the future. As AI starts to learn and see the world on its own terms, what incredible, unexpected, and amazing things is it going to show us? Thanks for tuning in to This Explainer.